Learning target 5.9 is finding the area of non-right-angled triangles. So before we do those formulas, let's talk about if you have the area of a right triangle, and this would be the base, and this would be the height. The area would be 1/2 base times height, or base times height divided by 2. Doesn't matter which way you think about it or type it in, it'll give you the same answer. So that's going to be the basis for our formulas that we use. But the height always has to be perpendicular to the base. So that formula only works if you have a right triangle. If you don't have a right triangle, whether it's acute or obtuse, then you have to rely on some of these other formulas. Okay, so one is where you have two sides in the included angle. So let's say we've got this side is A, and this side is B, and then we know this angle C, and we want to find the area. Okay, the formula for that would be area equals 1/2 A times B times the sine of C. So, for example, if we know a triangle is side A is about 7.5 centimeters, so we can label that as 7.5 centimeters. Side B is 9 centimeters, and then this angle would be, 100. I should probably draw a different diagram that matches that. If we've got, let's see, 100 degrees right there for side C, we'll say that's 9 centimeters and 7.5. And we want to find the area of that. We can plug those numbers into our formula. So we would say the area equals 1/2 times 7.5 times 9 times the sine of 100 degrees. And you can type all of that in at once. Make sure that your calculator is set to degrees since we're doing sine of 100 degrees. And we get an answer of about 33.2 centimeters squared. So you might want to pause the video, double check that that's the same answer that you get. And then if it is, then you can move on. The next scenario that we might have is knowing two angles in any side. So if you know two angles in any side, then the formula that you have to use is area equals 1/2 times c squared times sine of A times sine of B all over sine of C. And so the letters are arbitrary or they're random, just as long as the one side that you know is the same as the angle that's on bottom. So for this example, when it wants us to find the area where we know side A is 18.6 and we know angle A and angle C, we have to know all three angles to be able to plug in for A, B, and C. But the one side that we know is side A. So for this example, we'll say that area equals 1/2 A squared, which means we'll have to do the sine of B on top times sine of C on top and divide it all by the sine of A. And then again, it's just plugging in those numbers. I already know angle A and I already know angle C, but we don't have angle B. So for this problem, we'll have to do a little bit of side work of adding these two up and subtracting from 180 to get angle B. And so again, make sure that you can do that on your own. But angle B is 96 degrees and 50 minutes. So again, maybe pause the video there, add those up and subtract from 180 and make sure that you get the same answer. Now we can plug those all in and we can say that the area equals 1/2 times 18.6 squared times the sine of B, which would be 96 and 50/60ths, plus the sine of c, which would be, where was it? 63 and 50/60ths, all divided by the sine of a, which was 19 and 20 minutes, or 20 out of 60. Okay, so a lot of parentheses, a lot of things to be careful of when you're typing it into the calculator. But again, double check that when you type that in, that you get the same answer that I do, which is about 465.6. And our units was centimeters, and because it's area, it has to be centimeters squared. Okay. The last one is also called Hero's formula, but we use it when we've got 3 sides. And that formula says that the area is equal to the square root of s times s minus a times s minus b times s minus c. So obviously a, b, and c are the side lengths of the triangles, and they're throwing in this variable s, and that is where s equals 1/2 a plus b plus c, or you can do a plus b plus c all over 2. Okay, so for this last example, if we know a triangle and we know all 3 sides, but we don't know any of the angles, so we know this side, and this side, we can plug those all in. But before we do, we have to know what is s. So we'll do a little scratch work first and say s is going to be the square root of 2 plus 2 plus 3 all over 2. And we get s is about 3.207. Okay, so now we'll plug that into the formula and say that the area is the square root of that 3.207 times 3.207 minus the square root of 2 times 3.207 minus 2 times 3.207 minus 3. And that will be type all of that in, and I think you get that it's about the square root of 1.436, which becomes about 1.98. Well, oh, hang on a sec. That doesn't seem right. Okay, so that is, sorry, the area is about 1.198, and we could round that to say that it's about 1.2. Our units is feet, and so because it's area, it would be feet squared. Any of these formulas you could also sort of modify, or given some information, you could use the law of cosines or law of sines to find different information so that you could use any one of these other formulas. So for example, this one that we just did, where we know the 3 sides, you could use the law of cosines to find an angle, and then you could use either one of the 2 previous formulas as well. Okay. The problem on the next page, I'm actually not going to go through with you on this notes page. I'd like you to work on that with the people in your group tomorrow, or not tomorrow in class, but in class, where you're trying to find, so this is a problem from the book that sets up this family's plot of land is in an irregular shape. And if you want to try to find the square footage of this, it would make the most sense to divide it up into triangles and then find the area of each triangle. So I'm going to pose that as my challenge for you for tomorrow. And if you want a hint, I would recommend having one of your triangles be to use that triangle there. Okay. The next video is going to have the example on the next page about the area of a segment of a